thousands of different organisms that keep us all together. Without them, we'd be nothing. And we have today this advocate for the fungi kingdom. So honored to bring him onto stage. And I'm here with my dear friend, Stephen Brooks, because when we first met Paul in 2009,
yes, we met Paul in 2009. Our RVs were kissing in the Otters Oasis Burning Man camp. And I look over and Sarah's creeping through the window watching Paul drinking tea. She's like, Paul Stamets drinking tea right next door. And ironically and crazy enough, I migrated from that camp to the Bronner's camp, and so did Paul. And we've been good friends ever since. And ever since Envision started, every year I was like, Paul, come on, you gotta come to Envision. We're really trying to cultivate something really incredible. We got some serious mycelium spreading. We really want you to come down and share your message. And yeah, it took a little poking and many years of overlap, but it is such an honor to invite up a dear friend. And let's all just maybe take a deep breath together. And savor this magical next little time we have with the legend, the myth, Paul Stamets. Come on up, brother.
Well, I'm deeply honored to be here. Can everybody hear me okay? Yeah? So, you know, we live at a time-critical point in history, and we face some enormous challenges. But I'm confident that respecting nature and drawing from the intelligence of nature will give us the courage, the tools, and the knowledge for us to be able to activate ecologically rational and economically sustainable solutions. But we are in a super critical time where it's all hands on deck. So I implore all of you to pick up the ecological warrior mission, to carry these ideas forward into the next generations. This is a multi-generational effort for us to be able to save the biospheres of this planet. And each and one of us, all of us together, individually and collectively, I think can affect a paradigm shift. So my talk is expansive. It's a little bit scientifically dense. So I would just like to, there's a lot of diverse people here from a lot of different countries, but I would like just to have a show of hands. How many graduate students are in the audience here? Great. Well, I hope to fill your receptors, okay? So I do talk rather quickly, and when I use Latin binomials, I'll try to always use common words as well. So I just want you to sort of clear the fields of your receptors and be ready for a deep immersion into the microverse. So I always like to acknowledge my teachers. On the far right, I think on your screen, holding the baskets is Dr. Michael Bugh, and then across from him is Dr. Alexander Smith. Below Michael Bugh is Dr. Daniel Stuntz, and then Catherine Kit Skates. These are the four individuals that took me under their wing when I was 19 years of age. And this is something that's really important for me to communicate to other teachers, is even though I would say sometimes and often some of the stupidest things, just showing how ignorant I was of the subject, they never shamed me. Not a single time did they shame me. They would laugh with me, not at me. They would encourage my inquisitiveness, and they were excited that I would ask a question that they knew the answer to. That gave them some sort of, superiority, over me. But it's really important for all of you who are teaching other people, be kind and forgiving to those people who are not as smart as you, who show ignorance of the subject. We want to build bridges, not burn them. So much of my life's work has been spent in the old growth forest. And so when my friend Pam and I walk into the old growth forest, it's seemingly quiet, but it's actually bursting with information and knowledge and expressions, scent trails of mycelium, outgassing, that are stimulating our olfactory senses, that help us find different fungi. Fungi want to be found. They're engaging animals in order to spread their spores. So they entice us in all sorts of beguiling ways. So the biggest threat to the world today, is climate chaos, but climate chaos is a result of other factors that have created an equation of stressors. And you multiply that equation of stressors together, the opposite side of the equation is a massive loss of biodiversity. Foremost is a loss of our forests. This is what I truly believe. And I'm so gratified that some of the other participants here, one young man has spearheaded replanting tens of thousands of trees here in Costa Rica. That is just, these are the people that need our support. The people who are brave enough and confident enough to make that effort, not looking for recognition, but really realizing there's a higher purpose that serves the best interest of the commons. My manly man photograph. I spent several years as a logger hippie, and I cut down the old growth forest, and I have enormous respect for those forests, and I feel like I need to do a payback. Karmically, it's important that I pay back the forest. Nevertheless, my time in the woods was extraordinarily important for my education. And some of my logger buddies were some of the best people I ever met in my life. We depended upon each other, literally. 3 of them got killed, of a crew of 6. When they got killed, then they wanted me to be the head of the crew when I was 20 years of age. This is a summer job that I had, separate from college. So I really learned that it's so important that to respect people for their skill sets in life. They may not be academically highly trained, but these are some of the smartest people I've met in avoiding getting killed by trees falling down all around you. And believe me, you've got to have a really good wisdom on how to walk through the forest in order to prevent from being impacted by these massive trees. So nevertheless, I just want to give a shout out to all those people in the School of Hard Knocks. I'm deeply embedded in academia, but I'll never forget, and I do my best work chopping wood, doing manual labor. This is the time that I can be an autotron doing my manual labor, but my mind is just refreshed with oxygen and endorphins, and all of that just stimulates my brain. So I think that's something a lot of us also share. But this is something we also share as this planet. We've now entered into 6X, the 6th greatest extinction event known in the history of life on this planet. But this time it's not necessarily caused by an asteroid impact, it's caused by an organism, by us. Not only are we the cause of this extinction event, but we're likely to be its victim. There's about 8.5 million to 9 million species identified on this planet. We're losing more than 30,000 species per year. Do the math. In 100 years, that's approximately a third of the species on this planet that we lost in 100 years that got us here today. We are here today because of some very smart evolutionary choices, on the path of our evolution over hundreds of millions of years. But like rivets in an airplane, how many species, how many rivets will we lose before we have catastrophic failure? We're approaching that right now. It may not have as immediate of an impact as an asteroid strike. Maybe it would be helpful if it did. But it's happening over a few hundred years. But it's happening extremely rapidly. We are clearly at the tipping point. But we have this within our grasp to be able to make a difference. So I want to take you back in time and to show a shocking revelation. And this is some things, when I talk to indigenous peoples, and I talk to sages and people who are much wiser than me, there's some implicit truths that when you see them, you don't have to have them explained. You just understand. For me, what you're about to see is an implicit truth. So we'll start 13.8 billion years ago with the Big Bang, and the enormous amounts of debris jettisoned into the atmosphere, and then the universe formed. Those are parsecs, 3.2 light years across, 19 trillion miles. You look at the organization of matter, and it forms these vast networks. These networks are mycelial-like in their architecture. And then a deep field view of the Hubble telescope is over 180,000 galaxies in this one view. And those ellipses are galaxies in the web of dark matter, Approximately 90% of the matter in the universe cannot be seen, but this accounts for the reason why the galaxies are spreading apart and not crashing together. And the web of dark matter is the largest force the largest force in the universe. So we advance forward to 4.5 billion years ago, and as our planet had coalesced out of sawdust, our planet out of stardust, and a Mars-like planet called Theia crashes into our Earth. And from the rubble field, a lunar body forms, the moon. So from 4.5 billion years ago, only a few 100 million years later, now keep this in perspective, only a few 100 million years later, the first evidence of life became apparent. We advanced forward to 2.4 billion years ago, and the oldest representation of a multicellular organism recently discovered in the lava beds of South Africa, 2.4 billion years ago, the first evidence of a multicellular organism has been discovered, and it's that of fungal mycelium. We advance forward, and then 2.5 billion years around the same time, we have another visitor from the cosmos. This is supposed to be catching up here. It's coming. Brace for impact. You know, I can just change this real quickly. I know this well enough that this should work now. Well, it's a gigabyte file. This is what happens. So we have another asteroid impact. We have another impact from a celestial visitor, and this is an asteroid that came towards the Earth about 250 million years ago. It comes in and slams into the Earth, and it's in slow motion. I will not be defeated. Well, maybe I will be. It's still out there. We have more time. You know, I'm going to see if this thing catches up to itself. And if it doesn't, then I'll just move on. Coming down. In real time, this happens a lot faster. Okay, I think I'll just progress from here. But it slams into the Earth. The enormous amount of debris is jettisoned into the atmosphere. Sunlight is cut off. Plants and animals die. It's at the Permian-Triassic boundary. Enormous extinction event, and fungi inherit the Earth. The fungi reach up from the soil, start decomposing the plant and animal material. And at a PT boundary, there's a distinct layer that signifies this extinction event. Well, when looking into the fossil record at the PT boundary, there were actually found the predominant fungi that gobbled up the debris fields. It was given a name, Reduviosporinites. And this was a fungus that was dominant in the fossil record that was at the interface between life and death. And as it decomposed the material, it then released nutrients for other members of the ecosystem. Well, we go forward now to about 420 million years ago. And in the fossil record, this was discovered in the mid-1800s. For a long time, it was a great controversy. They didn't know what it was. And this is at a time before vascular plants, before flying insects. And this massive fossil was given this name, Prototaxides. And it wasn't known until Kevin Boyce was able to finally determine what it was, working from the University of Chicago. 420 million to 356 million years ago, Prototaxides was the tallest organism on land, and it was a giant fungus. 30 to 40 feet in size. It would the tallest organism on land. It would attract lightning strikes epigenetically because of the ionization and lightning strikes. It would cause genomic influences in the resident microbiome that was living on and within this giant fungus, and it would steer the course of evolution. We march forward to 110 million years ago, And recently in Brazil, it was found in the fossil record a perfectly shaped mushroom. That's 110 million years ago. Mushrooms had their form long before we had ours. Now think of that. So, let's see if this one works. And then we go to 65 million years ago, and we have another celestial visitor. We have another impact from an asteroid just around the Yucatan Basin. The same story repeats itself. Enormous amounts of debris jettisoned into the atmosphere. The dinosaurs, of course, became extinct. Massive extinction across the planet. And then fungi re-inherited the Earth. There's a recurring theme here, folks, is that when you ally with fungi, you can survive extinction events. Now, this is really important for you to understand, is that we actually split from fungi 650 million years ago. Fungi gave birth to animals. We are descendants of fungi. We are descendants of mycelial communities. We are descendants of these multicellular networks that set up the microbiomes within ecosystems. And we are now the organism that's predominantly influencing this planet. But we cannot forget for a moment that if we trespass on the sacred rights that our ancestors have given us, then we will be extincted out of the biosphere. Extinction is a normal consequence of life. 99% of all species that have ever appeared on this planet have become extinct. Extinction is the rule, and it's not the exception. For us to continue as the exception to extinction, it's really important that we be able to protect the biospheres that have given us life. So Gondwana land and Pangea formed, Pangea first and then Gondwana land, with continental drift, and the continents then spread and separated into the new and old worlds as we know them, and after continental drift, the planet is as we basically see today. So I want to now show you how these fungi work within the ecosystems. This is the Mycelium cubensis, growing over about 5 days. It's a network that constantly divides and splits. And then mushrooms form from the mushroom mycelium after an arduous and long path where they're being constantly challenged in the ground. The mycelial networks are being attacked, and then they develop commensal associations with beneficial bacteria and other organisms. And that consortium of individuals working together, that guild that is predisposed by the mycelium, selects out the microbiomes that then give the community sustainability, then to give rise to the forest, to create the debris fields to feed the mycelium. So the mycelium is deterministic, but the mushrooms only form for a few days. They're the virtual tip of the iceberg. And so the mushroom fruit bodies, frankly, don't have a good immune system. They're designed to rot. They're designed to be fleshy and attractive and nutritious, for the benefit of other organisms in the ecosystem, because their spores need to be spread. And so what better way is to entice animals to be able to feed upon these fleshy, young, succulent fruit bodies so the spores can be dispersed further and further. The largest organism in the world is the mycelial mat in eastern Oregon. It's over 2,200 acres in size, 1,665 football fields, and it's the mycelial mat of a honey mushroom, an edible mushroom that is parasitic upon trees. This is the outline of this mycelial mat. Now, this was reported in a scientific journal. Well, that was almost prophetic. So when this article was published showing this largest organism in the world, they had the latitude and longitude coordinates. And so I hired a small airplane, literally an airplane with a canvas cover, and a bush pilot from Alaska. We flew down there, circled over the location, but we couldn't see it. We saw lots of dead trees, and the trees are ashen gray, and they're a fire hazard. The Forest Service comes and cuts them down. So I was disappointed I couldn't see it, so we went back to the Boeing field. The next day we went out again, we checked our coordinates, the coordinates were correct, but we weren't high enough, literally. And so we returned and we spiraled up and we spiraled up. And we got up to about 14,000, 15,000 feet. Now, for those of you who've been flying in small airplanes, we went from sea level to 14,000 feet in about 45 minutes. And so finally I saw this out the window. And I opened up the window and I told the pilot, I need to get a photograph of this, but I think I'm going to faint. And the pilot said, me too. I said, wait, let me get a photograph. So anyhow, I'm proud of this because it took some effort to be able to get it. So the mycelial mat is visible literally from space of this organism. But deep down in the earth and all around us, every footstep that you take, are these mycelial mats. This is a movie by my friend Patrick Hickey from the UK. Prior to him doing this time lapse over several hours, we didn't know that nuclei of mycelium would bundle up and travel through these networks. And epigenetically, as the mycelium spreads out, and we've done these calculations, there are trillions and trillions of end branchings. And so the mycelium becomes polynucleate. They usually segregate into 2 nuclei per cell, but at the tips of the mycelium, there can be hundreds of nuclei at the newly forming tips. And they're like little scientists doing experiments. And epigenetically, they found a new toxin, a new food source, a new insect. If they can code for new enzymes that can unlock that nutrition, what happens? The mycelium surges. And then that information gets back channeled to the intelligence of the entire mycelial network. So these are learning membranes. And so the mycelium is a network-like design because of evolution, because it gave the best possibility for exploration and coding for new successes and being able to survive environmental challenges. So the organization of the mycelium conforms to the computer internet. Diagrammatically, it's an example of that, of mycelium, of dark matter, of brain neurons. I don't see this as happenstance or coincidence. I see this as a deterministically, evolutionary successful, previously proven biological model, and that shows the rewards of networks and being able to share information. So the mycelium grows out and produces extracellular enzymes. And in these droplets of moisture, they're packed full of all sorts of micromolecular compounds and unique enzymes. Over 250 novel enzymes have been found specifically secreted from mushroom-forming fungi, heretofore not known to science. The mycelium, as it digests a substrate with wood and sawdust, as an example of the oyster mushrooms, 25% of that dry mass becomes water. They are inhaling oxygen, exhaling carbon dioxide. So mushroom mycelium responds and produce mushrooms in response to 4 primary environmental stimuli. And that is the drop of temperature coinciding with moisture. So you have rain, then dropping of temperature. And then we have dropping of temperature, the mycelium comes up to the surface because it's more moist. And so it comes to the surface, an example here, there's a root of a tree there, there's a lens of mycelium growing, and it exhales carbon dioxide, inhales oxygen. And surprisingly, the vast majority of mushroom-forming fungi are phototropic. They actually are stimulated by light. They need light in order for the mushroom mycelium to form. And it may be a response for the fact that the mycelium has now finally come out of the ground, exposed to the air. So those 4 primary stimuli control the formation of the mushroom fruit bodies. So the mushroom mycelium is this wonderful fabric. Under those 4 environmental stimuli and gathering enough nutrition as a baseline precursor, then little aggregates of mycelium begin to form. These are called primordia, little baby mushrooms. And the mushrooms then form and they grow explosively. They grow in the matter of 4 days from something that's a pinhead, that's microscopic, beyond your visual acuity, into something that can be massive as a matter of several pounds. The mushroom mycelium is particularly tuned into blue light. And I will give a talk the day after tomorrow in psilocybin. I encourage all of you to come. It'll be a very enlightening talk for a lot of you. And it'll be also something that many of you are most familiar with, being in hyperspace, I'm sure. So the mushroom primordia form, and so from that primordium to a fully mature crop of Psilocybe cubensis, for instance, is about 5 days. So that's how quick these things form and mature. And temperature drives the mushroom life cycle. So within isotherms, depending on the temperature, of the within the isotherm. It can slow the crop down maybe to 8 days. It can speed it up maybe to 4 days. But operationally, you know, with philosophy convention between the temperatures of 65 degrees Fahrenheit and 85 degrees, 90 degrees Fahrenheit, that's the operational window. But temperature controls the metabolism within a very, very narrow range. So the mushrooms form, and then they begin to decompose. And they sporulate. And then coming back to this russula mushroom in the old growth forest a few days later, spores are germinating, lots of other organisms are co-occurring, and then the mycelium forms and then goes underground. There can be more than 8 miles of mycelium under a single inch. Now think of that. My foot covers about 300 miles of mycelium in this photograph. The mycelium networks are pervasive. They're everywhere. They're sentient. These are not only neurological networks that can learn from epigenetic contact with other organisms because of the polynucleate nature. There are not only digestive membranes that are digesting things, so these are externalized stomachs. They're not only externalized lungs, exhaling carbon dioxide, inhaling oxygen, but these are the underlords of nature. They are controlling and designing the ecosystems for the best benefit of the plurality of the community to best preserve biodiversity and sustainability. So they do not look and operate in terms of their own lifetimes, but with the framework of successionism, for the benefit of the commons and the biodiversity of the community, which gives the ecosystem diversity and resiliency and sustainability. They are truly organisms that we can all learn from. So the soil networks are highly connected by mycelium. An interesting article was published in Nature. And when you have disturbed soils, and most of the gardeners know this, when you have leafy vegetables and you garden, bacteria come in really quickly. The garden vegetable leaves become slimy with bacteria. Bacteria predominate, and when these ecosystems then return to near natural conditions, it's the fungi that then dominate in the ecosystem. And more than 70% of the carbon that we find in soils is resident within mycelium, the majority of which is dead. And so there were calcigen deposits of thread-lights of carbon, these carbohydrate structures and polysaccharides that build mycelium resident within the ecosystem. There is more mycelium stores more carbon in the atmosphere than any other organism on this planet. So by investing in soil, you're investing in creating soil, mycelium creates soil, you're investing in the carbon bank. And this then gives the soil the ability to produce massive trees, and of course the old growth trees are the biggest repository of carbon above ground. Mycelium is the biggest repository of carbon below ground. So a friend of mine introduced me to this artist, and I co-designed with this artist this image. And my talk later on will go into bees. But it was fascinating to work with this artist who was totally tuned in to fungi and nature. And the benefits that we all reap from fungi, a lot of it is unobvious to many people. You consume your food, you think, great, it grew from a garden. Well, the garden came from soil, fungi created soil. And so it's really important that you understand by investing in mycelial networks, you're capitalizing the carbon banks that will be able to give you the foods and nutrition that are necessary for you to live. So I'm going to jump into a whole bunch of different species real quickly here. This is Enokitake. It's a mushroom called Flammulana volutipes, or Flammulana populicula. And it is a velvet-stemmed little short mushroom called the winter mushroom, and it grows on stumps and on dead logs, both conifer as well as deciduous woods. It has an elongated stem. One of the truths of us cultivators that we know is carbon dioxide controls the length of the stem and light controls the diameter of the cap. So you can morph your crops to have long stems and small caps by changing the gaseous exposure or by changing light conditions. So enoki mushrooms are velvet stem mushrooms that are grown in really low light conditions, so the cap is small, really long stems. Well, interesting research researcher by the name of Ikikawa, who I had the good fortune and pleasure of knowing. He visited me. He was one of our keynote speakers at a conference that we put on. He was working for the National Cancer Institute in Tokyo. And they noticed in the Nagano prefecture, there was a dearth, a statistically significant drop in the average cancer death rate in Japan. And so he was sent there as an epidemiologist to do a survey with the citizens in the Nagano prefecture to see what lifestyle or foods that they were consuming that could be explained why there was a significant drop in cancer rates in that area, mountainous area of Japan. So there is approximately, the cancer death rate is around 160 people per 100,000 per year. More men dying than women. Men don't live as long. So it was interesting when he started then getting and disambiguating the data, he found that it was localized around families whose members worked at enoki mushroom farms. And so he published this. Now this is 174,505 people in this epidemiological survey. Statistically significant drop in cancer rates across all cancers. So he wasn't going after one type of cancer, he's looking at average cancer deaths. I'd like to give Dr. Ikikawa credit because he is the one that I think, when he published this in a peer-reviewed immunological journal in English, I think that was one of the pivotal articles that showed that mushrooms empower the immune system to allow you to be able to fight the challenges of cancers and all of its iterations. Another article just came out this past year, just a few months ago, and basically it shows that mushroom consumption, the incidence of prostate cancer in Japan. This is a polled analysis, and 36,499 men that were polled, and basically there's about a 30% drop in prostate cancer deaths for those men who consumed more than 3 meals of mushrooms per week. Now they didn't delineate whether they're button mushroom, shiitake, enoki, but in Japan and in Asia, shiitake, enoki mushrooms and bunohan shimeji, these other wood decomposing mushrooms are eaten in much higher quantities than button mushrooms. Button mushrooms are a recent arrival. Another meta-analysis came out, and this was monitored over from 2011 to 2017, 663 men and women. And they found a 50% reduced odds of having mild cognitive impairment for those individuals who had 2 standard portions of mushrooms per week. So, very interesting. There's an extension of life, a reduction of cancer rates, and an increase in cognitive function associated with the biometric of those individuals who are actually consuming these mushrooms. So this is important because it's really hard to figure out what is a causal mechanism that is empowering the immune system. Now, what scientists first looked at was beta-glucans. Well, what are beta-glucans? They're highly variable in their molecular mass. These are polymers of sugars. And when you look at them, they can be just 10 or 20 Daltons. They can be 10,000, 100,000, a million Daltons in size. These are massive, massive polysaccharide structures. They activate the immune system in your gut. They never make it into your blood. But the dendritic cells then respond as if you have consumed a pathogen. This is the old school model that immunologists have used, that's thinking that fungi are poisonous and your immune system responds because you've eaten something that's poisonous. So they code for beta-glucans as antigenically as if you've consumed something that's dangerous. Well, it's much more complicated than that, I think. And I believe beta-glucans are giant scaffoldings. And within the scaffoldings of the beta-glucans, it's like the structure of your house, and they're made of wood. But the contents within your house, it hosts all these other exotic molecules, especially fatty acids and polyphenols. And it is these compounds that we now know are upregulating the immune system in a way heretofore not understood. And it speaks also to species specificity. Because if there's just beta-glucans, you can get it from yeast, where all mushrooms are the same. And we know that's not true. We knew there's species specificity factors in different mushrooms having different immunological benefits depending on this mushroom species that you consume. All mushrooms are not alike. Well, the most well-studied mushroom in the world by far is turkey tail. Stamets versicolor. The old name is Coriolis versicolor. This mushroom has been eaten and consumed for thousands of years. It's the best recorded mushroom in the scientific literature. And there was an article that was published in The Lancet in 1994 by Nakazawa that showed a statistically significant increase in the 5-year disease-free survival rate with those with colorectal cancer. About a 17% significant increase in lifespan. That's huge, in conjunction with conventional therapy. Now, Chimades versicolor is called versicolor because it's variable in color, and it can be just gorgeous. This is one of my absolute favorite forms of turkey tail, this blue form. So, turkey tail became a subject of Western studies, trying to look at how we can empower the immune system, the host defense of cancer patients. And so we applied for a grant with the National Institutes of Health, myself, my colleagues at Bastyr Medical School and the University of Minnesota Medical School, and we received a $2.2 million study for breast cancer patients and turkey tail mushrooms. And so we're extremely excited about it. We got this grant. I wrote several pages of the grant. It was a team effort, and they go, "Great, Paul, you're a mycologist. Now, where do we get the mushrooms?" And I said, "Oh, please don't get them from China. You need to get a chain of custody, which means you need to be able to track down to the original cultures and have all the documented steps in this production. When you buy in the spot market, you don't know where that mushroom came from, all the contamination it had, the exposure of heavy metals. You don't have a clear understanding on how that mushroom product was managed to the point of human consumption. This is the transparency is super important with medicinal mushrooms." So we received the grant, and they said, "Well," I said, "You can get them from us." And they said, "You can't, because you're a co-author in this study. It's a conflict of interest." So I resigned as a co-author in the study. They then juried 5 other sources, thankfully, because we had the chain of custody and the evidence. They chose us. Now, about that same time, my family faced a critical challenge. And the challenge was that my mother got a hold of me, and she told me the worst news I think a son can ever hear is that she had advanced metastatic stage breast cancer. It was advanced stage 4. She had not seen a doctor since 1968. She was a charismatic Christian. And she came to me saying, "Paul, I only have a few months to live." The doctors gave her less than 3 months. And then her oncologist said, "You're too old for a breast cancer removal. You're too old for radiation therapy." She was 83 years of age. But the doctor said, "There's an interesting study on turkey tail mushrooms for empowering the immune system. You know, in Seattle at Bastyr Medical School, you may want to take those." And so my mother said, "Well, my son's supplying those." She got real excited. And so she had to hear from a doctor before she allowed her son to give it to her. It was like, "Mom, I'm over here." And so she started taking 8 turkey tail capsules, 4 in the morning and 4 in the evening. So here's my wonderful, wonderful mother, and she left me the following recording, which always brings tears to my eyes. So here's a little bit of Mom. Nope. Come on, Mom. Aw. Oh my. This is what happens, folks. But anyhow, my mom called and stated that, you know, she got the final report 6 months after taking Herceptin, which is a great drug, in combination with turkey tails, and she was breast cancer free. She had no detectable tumors whatsoever. So now my mom passed away on March 1st of this past year. She lived to the age of 93, so she was well beyond the bell curve. She led a wonderful life, and she was a real trooper and a wonderful and a kind person to me, so I miss her deeply. And the clinical study was published. It shows a dose-dependent response of the immune system, depending on how many mushrooms mycelium you would take. It was based on mushroom mycelium, not fruit bodies. Statistically significant increase in cytotoxic T cells. If those of you know about statistics, they have that p-value with 3 or 4 zeros in front of it is hugely significant. There's no chance for statistical error. So we published this in a journal of oncology, and then the researchers and we were getting these debates about beta-glucans. And I said, it's far more complicated than just beta-glucans because of the scaffolding. And so, subsequent to my mother's report, it was written up in the medical journal, subsequent to our study, then scientists there at the University of Washington Medical School began to test the combination of turkey tail mushrooms with Herceptin as a chemotherapeutic drug. And they found that turkey tail actually enhances the activity of Herceptin. So we look at beta-glucans, there are the extractions, different solvents. Water is the most polar of solvents, so it pulls out most of the beta-glucans and polysaccharides. Well, lipids are not soluble in water. Most of you know that. You pour oil into water, it doesn't dissolve. At higher temperatures, it becomes more miscible, but then it separates upon cooling. So when you're looking at the spectrum of solvents for pulling out the active ingredients, I encourage my colleagues, why don't you do a study and separate out the beta-glucans from the lipids? And they did so. Now, PSK is a protein-bound polysaccharide from turkey tail, and when they use a lipase, basically a lipid-dissolving solvent, an enzyme, that stripped the lipids from the beta-glucan scaffolding, it decreased the immune response by about 83%. That's phenomenal. Without beta-glucans, just with these polyphenols, these lipids, the immune response was much higher than with them versus without. So we really showed and blazed the way that this massive molecular complex, which is wonderful, but it hosts within it all these other compounds that are resident. And that residence, those other residents within the beta-glucan scaffolding do make it into the bloodstream, do activate immune response. And there's something that should be explored in greater detail. The other thing about turkey tail that's so interesting, it's a prebiotic for the microbiome. So even though some of these substances may not get into your bloodstream, they encourage the production of beneficial bacteria, Acidophilus, Lactobacillus, and Bifidobacterium, and suppresses the growth of Clostridium and other inflammatory and pathogenic bacteria. So we now have a better understanding that our microbiomes are really different. And when you start conditioning your microflora, your bacterial microflora in your gut, your microbiome, with mushrooms, then it sets up healthy microbiomes that allows you, that it also affects the rest of your health. So this is an extraordinary finding because it also speaks to the fact that we've all met people who say, and I've heard this so many times, mushrooms are interesting, but I can't, quote unquote, stomach them. Well, to me, now I realize that I can't stomach them. It's actually a very good case report of an individual who probably has a mismatch of a microbiome. And so some people out there, just can't digest mushrooms because the microbiomes are mismatched. So there are many other complexities to medicinal mushrooms. And one of the biggest ones, by far, is the importation of Chinese mushrooms to the United States and probably to Costa Rica, I don't know for sure, but all over the world, because of international trade agreements, the Chinese producers can use USDA organic. And 99% of the people think, oh, if it says USDA organic, it must have been grown in the United States. Not true. So the Chinese mushrooms coming in the United States, they're stamped USDA organic, don't identify the country of origin. I think all foods should have the country of origin.
Yeah.
But the lobbyists have now prevented us from having full truthful disclosure, and so the public is being tricked. So now the amount of heavy metals in some of these Chinese mushrooms are actually dangerous to consume. This comes from a well-known Canadian distributor who is a majority distributor of medicinal mushrooms from China into the United States and Canada and elsewhere, directly from their product. Toxic levels of mercury. If you would eat the recommended dose that was on the package, you would actually be getting toxic doses of mercury. This is something that you should be very concerned about. There should be truth in advertising, truth in the country of origin, and there should be certified analyses showing that the products are clean. Mushrooms are the reflection of the environment in which they grow. So for heavy polluted environments, I've been to China several times. If you've been to China, folks, when they come up with a propaganda that says China's airs are clean of pollution, do you really believe that? I mean, those of us who've been to China, we know we're gasping for breath. We can barely, inhale because of that toxicity. So no matter where you get your mushrooms from, here in Costa Rica, fabulous ecosystem. Different regions of the world have clean ecosystems. But just make sure that you know where your mushrooms are coming from and be very skeptical. It's really important that you know that. The other thing that has come out from whole genome sequencing is there is about 25% more genes are activated in the mycelial state than in the mushroom fruit body state. Well, that makes sense. If the mycelium is navigating, there could be several million microbes per gram as the mycelium is running through it, many of which are hungry, trying to attack the mycelium. Because of the upregulation of the immune system of mycelium, it codes for antibiotics and defenses that can prevent these parasites from consuming the mycelium. It also sets up those commensal guilds. So there's much more bioactivity at the mycelial stage than the fruit body stage. Well, that makes sense also because after months, years, then the mushrooms form, they rot in 5 days. Good luck to any bacterium that's going to rot that mushroom before spores are released. So the intelligence of mycelium, the innate immunity, the depth of the library of defenses that mycelium has is a treasure trove for us to be able to explore. So I spend a lot of time on mycological adventures, and this is one of my favorite, the search for agarikon. And I have a place up on Cortez Island, British Columbia. And so I won an award from National Geographic, and they wanted to come out to do a story on me on agarikon, which is, you'll see in a minute, it's a very big polypore mushroom, grows in the old growth forest. They didn't want me to take them to a place to find it, that I've already found agarikon. They wanted to have the eureka experience of a novel adventure. Now, how often we find agarikon? 1 out of 100 trips in the old growth forest. My dear Professor Michael Bugh found his first agarikon about 2 years ago. After 40 years of going dozens of times in the old growth forest, he found his first one. That's how rare it is. But I didn't want to disappoint National Geographic, so they asked me, how likely is we'll find an agarikon? I go, 50-50, maybe. But I took 10 of my friends with high-powered binoculars, and we scanned the horizon. Because these big agarikon, often their bald eagles are in the trees, they're living snags, and they look like a giant bee's nest. And so we looked, we couldn't find it. So we were real tired, and we wanted to take a break, and so our skipper said, well, let's go over to a First Nations site that's sacred, and let's have lunch there. And so we went there, and we got closer and closer, and sure enough, we found it. So here's a little 2-3 minute audio. Hopefully this will work. So take a listen. Now we don't have audio on this. I think these two things might be interrelated. Tech team, how you doing? Come on, tech team. We start again.
Hi folks, I'm going to do a deep dive and sort of an immersion in some of the knowledge about agarikon that we have present and the potential of agarikon for many new discoveries. The first evidence of agarikon we have is from Dioscorides in 65 AD in the very first Materia Medica, in which Dioscorides described this as elixirium ad longum vitam, the elixir of long life, specifically used for treatment of consumption, later thought to be known as tuberculosis. Well, indigenous peoples also revered this mushroom and would carve this mushroom into grave guardians to help shamans go into the afterlife. Now, whether you're a physician or a shaman, you hold in common the concept that diseases can be caused by the invisible. The shamans will call them spirits, doctors will call them microbes. And in this case, we know this mushroom has very, very potent antibacterial, antiviral properties. We're with Dr. Scott Franzlau at the University of Illinois Chicago Tuberculosis Research Center. We have discovered through bio-guided fractionation, taking the mycelium in these mushrooms, and by doing a decision tree of using solvents, We go down water as being the most polar of solvents, using hexane, which is a non-polar, and then we test those fractions to see if the increase in the anti-tuberculosis activity occurred. Then we follow the decision tree that leads us to increased potency. They did this over several years, and then we finally found a group of chlorinated coumarins that are published in the Journal of Natural Products. These chlorinated coumarins are highly active against XDR, multi-drug resistant strains of tuberculosis. Moreover, working with the Bioshield program, the U.S. Defense Department, we discovered that the mycelial extracts, just simple mycelium put into water and ethanol, when we took the supernatant, after the polysaccharides are precipitated, the supernatant, the clear fluid at the top of these vessels, had within them extremely potent properties against pox viruses, herpes, as well as flu viruses. Working with the University of Mississippi School of Pharmacy with Dr. Samir Ross and his team, they did biogat fractionation, and lo and behold, we found 2 novel anti-smallpox molecules. And these molecules are more potent than cidofovir. And these molecules are open source because hopefully we'll never have a smallpox pandemic. The anti-flu molecules have not been discerned, nor the anti-herpes molecules. But the point is, this mushroom is a deep reservoir of pharmacologically active agents, dually active against flu viruses and pox virus and herpes viruses, as well as against tuberculosis bacteria, staph bacteria, and E. coli. And I think this mushroom presents a fantastic bioshield of defense. Ancient peoples knew this empirically through thousands of years of experimentation, and now modern science is understanding this better. This is the form, that's the brown form, and it goes into the quinine form, the white form. And behind me was a white form of agarikon known as a ghost form. Now the quinine form is reported throughout the literature, being used in tinctures, etc. We do have one anecdotal report from a First Nations shaman who ingested the white form in large quantities and reported temporary blindness. So I caution people not to make extracts out of the fruit bodies. The mycelium is a whole other matter, and this mushroom is considered to be endangered in some ecosystems because it's only associated with old growth forests in the Pacific Northwest, Northern California, Oregon, Washington, and British Columbia, and a few sky islands in Austria and Slovenia in the Alps. So another example that the biodiversity of our ecosystems have within them a wealth of potential solutions to the diseases that afflict us today and the diseases that afflict us in the past. So I think this mushroom has enormous potential for further research. We're dedicated to exploring it more, and the latitude, the elasticity of applications of this mushroom, I really speak to its intrinsic value. That's it. Thank you very much.
Whoa. That was a download. So that's the mushroom that we found. We went there and it was behind us, and this mushroom actually fell from a tree limb above it. And it hit that lower branch, it teeter-tottered, and then the mushroom mycelium from the mushroom grew back into the tree, and then it grew 2 legs. So that's an extraordinary, it just teeter-tottered there long enough for the mycelium to hold onto it, and then it grew 2 legs. So I'm there with my friends, and my friend Pam and my daughter Ladina, we've been here several times, and this rock is just crazy. And you look at the rock, you look at agarikon, you look at the rock, you look at agarikon, you look at the rock, you look at agarikon. I mean, how unusual that we'd find this place that, would have an agarikon, also have a rock that looks so similar to an agarikon. And it's also a First Nations site, and prior to the advent of Europeans that brought flu viruses and smallpox and sexually transmitted disease and tuberculosis, the First Nations are described by medical scientists as being immunologically naive. Genomically, they have never had contact with so many diseases. Their immune system could not code for antibodies to be able to protect them. So this is, I think, is full circle. And like I mentioned, whether you're a physician or a shaman, to understand that diseases are disruptions in the invisible world. And the scientists will call them microbes or viruses, shamans will call them spirits. There's a unity of consciousness and understanding that these diseases are caused by the unseen. And to be able to boost the immunity of the individual is key for tipping the balance in their favor. So this is another example of agarikon. It's about 35 years of age. Those are growth rings, annual growth rings. Dr. Scott Franzbaum, the director for the Institute for Tuberculosis Research, funded by the Gates Foundation. We went there, and this is an arge-like plague with the Haida people. My good friend Gu Zhao is one of the lead shamans of the Haida Gwaii. It used to be called the Queen Charlotte Islands, but that was the ship that brought in smallpox, and so the First Nations use Haida Gwaii. That's their native name for it. And so there's there's another mushroom called the artist conch. But in the origination of the myth of women of the Haida culture, no one could help Raven, who's in the bow of the canoe, succeed in her quest for her femininity. Not the bear, not the killer whale, not the eagle, only fungus man, agarikon, potentially the artist conch. This fungus was able to help Raven steer and be successful in her quest for her becoming a woman. So it's some very, very ancient roots. And now this mushroom, as I mentioned, also was first described by Dioscorides in 65 AD. So you have it not only in European culture, you have it in indigenous first peoples who had also discovered this mushroom as a very, very powerful medicine. Sometimes it's very, very hard to get. So we have to scale up trees, hundreds, 700-year-old tree. This one's about 80 years old. We cloned this. We took a small piece of tissue and we preserved it. It's a good thing we did because the storm came and this tree got toppled, and this agarikon now is lost. Unfortunately, a street crew cleaning up the storm debris picked up the agarikon and threw it away. So I was very happy that I was able to get a culture of it. And how we don't collect these unless they are the ecosystem is being destroyed. We leave them in place. We take a stainless steel tube, we go in and we take a small sample of the mushroom, and then we plate it out in the laboratory, and here are 4 different strains of agarikon. Now, this one agarikon on the right there, the large one, with a guy from Northern California, can you tell? NorCal. He has the biggest agarikon I've ever seen. That's over 100 years of age. That's how mammoth these things get. So we published this anti-tuberculosis activity from agarikon, the Journal of Natural Products. And so this was still continuing to be some research. Now we're testing agarikon against Lyme disease, Borrelia, also a bacterium. It's like mycotuberculosis is Mycobacterium tuberculosis, the bacterium, so is Borrelia, Burkhardia. So this is a mushroom that we find to be extraordinarily non-toxic in the mycelial state. And we have a group of scientists at our company. We have 3 PhD scientists working full-time, and we're publishing about 2 peer-reviewed articles per year. And the next article we're publishing on agarikon is just extraordinarily interesting on how powerful it is as an antiviral and antibacterial, and how anti-inflammatory it is. This is really important when you look at these. Well, around 2001, I published this paper in Herbalgram, and I was surveying the scientific literature looking for novel antivirals of mushrooms. I found almost nothing in the literature except for the gypsy mushroom, Rosaites caparata, an edible and choice mushroom, and it had a compound called RC138. And this mushroom the compound was discovered by Dr. Frank Perano, a physician from the University of Washington Medical School. And when I was about 22 years of age, he wrote me and he said, "Can you collect just gypsy mushrooms? I need, lots of them." So my professor asked me to, and I shipped about 20 pounds of gypsy mushrooms to him, and he isolated this new antiviral compound, highly active against herpes simplex 1 and 2. And so in the survey in 2001 that I did, I just found a few examples. And I published them, and then that was in June of 2001. September 11th, 2001 occurred, the attack of the terrorists against the World Trade Center, followed soon thereafter by an anthrax attack. And a physician in the Bioshield biodefense program, funded by George Bush for several $1 billion, Project Bioshield, specifically was trying to find new ways of combating against weaponized pathogens. In particular, viruses. Anthrax is a stupid and very localized terrorist weapon. It only kills people in direct contact. Viruses, as you well know, especially in the news, they can jump from person to person to person. And so viral pandemics and also being able to protect against weaponized viruses became extraordinarily important. I was greatly honored that they accepted me, especially in my history. And so I got archived in, and we submitted thousands of samples. Mushrooms, the mycelium that grew the mushrooms, different extracts, different preparations, etc. And we did this for a very long time. And we actually, when the first reports came in, Federal Express delivered me 100 pages of test results on smallpox, and I'm flipping through the results, and I didn't tell them what mushrooms they were. They're just coded ones. And I'm in no activity, 78, high activity against pox viruses, 79, high activity against pox viruses, 84, high activity. And I went to my decoding notebook, and they were all agarikon. I went, wow, I got really excited. And so I called up my handler at Fort Detrick, the Department of Defense, and he said, "You're not supposed to get those results, I am." And I said, "No worries, I'll photocopy and send them to you." they were so disorganized. And this happens with the government all the time. And then, this is a true story. I was in Canada, and one of my senior employees said, "Paul, I gotta talk to you, it's urgent." I said, "What's wrong?" He said, "There's a helicopter over the laboratories." I said, "No problem, helicopters come by all the time." He said, no, it's really close. I said, "How close?" He said, "Listen." Choom, 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 choom. I go, "Whoa." He said, 100 feet over the helicopter, over the property, over the laboratories. I go, "What's the number on the tail?" He says, "There is no number. It's a Black Hawk helicopter." And so the government tried to spook me because I may have found the antidote to smallpox that could be weaponized. And so I actually got pretty upset because I called back my handler in the Defense Department and said, "Don't you guys talk to each other? I've already been vetted, you know?" And he apologized and said, the government doesn't talk to different branches, et cetera, et cetera. So as crazy as that all is, it's true. And then we published them, and we found some very novel molecules highly active against smallpox. How many people are immunized against smallpox? Maybe 1% of you. You're immunologically naive, which means that there's a smallpox pandemic today. 1/4 of you would die within a week. 1/4 of you would be blinded for the rest of your life. 1/4 of you would be horribly scarred, smallpox sores, and 1/3 of you would live. If you're indigenous in your origins, 90% of you would die. This is the problem that we all face as a community, is communicable diseases, especially viruses. So you can go to National Public Radio, Google Stamets, smallpox, NPR, National Public Radio. You can hear an interview with myself, the Deputy Director of the FDA, and the head of the Bioshield program. We are in the top 10 of more than 2 million samples that were submitted to the biodefense program that were active against pox viruses, and we were the only natural product that have any activity, all based on the mycelium of agarikon. We further went on, as I mentioned in the video, and we found 2 anti-pox molecules that are resident with the agarikon mycelium that are highly active and more potent than tenofovir, the positive drug control. Well, we are now entering the time of viral storms. I've been speaking on this subject for a long time. I know a lot of virologists and scientists, and they're wondering why haven't we had the next pandemic? I've been saying that for years, and other scientists have as well. Well, you know what the next pandemic is. We've all heard about it. But the other pandemics of 1918, 2.5% of world population died, millions and millions of people. H5N1, 60%, H7N9, 2014, 70% of the people. Fortunately, those were not very communicable comparative to normal flu viruses. So these viral storms occur, and with factory farming in particular, and the deforestation and the crowding of animals, zoonotic diseases now are spreading, leaping from animals to humans. And cross-special transference of these viruses are also occurring between animals. So there's a mixing of the viral genomes that are making them more and more contagious. So there is a measure of the Bioshield program. Anything that having 2 or more is active against a virus, a compound, anything 10 or more is highly active. Well, the Bioshield program surveyed 2,392 samples that we submitted between the years of 2003 and 2009. Remember, those numbers, anything over 10 is highly active. So ribavirin, which is a positive drug control, we tried agarikon, reishi, chaga, and then a 3-species blend. And there's ribavirin, 170, 132. Our mushroom extracts of Mycelium, 320, 190, 110, a combination over 1,000 on the selectivity index, showing highly potent antiviral activity. Well, we go forward, and I was finally issued a patent on this in 2014. I filed the patent in 2004, but I got quarantined by the Defense Department as a matter of national security. For the same reason that you can't publish a patent on a nuclear weapon, it becomes a blueprint. And the idea was if this information got out, then terrorists could use it as a protectant, and then they could unleash a bioweaponized virus. Finally, we got it out of quarantine. We interagency trace between the patent office and the U.S. Defense Department, and the patent then had a universality of approval with no prior art stating that this patent was valid. So I got my first antiviral patent after 10 years in quarantine. And during that time, at the Vector Institute in Russia, which also is the institute like Fort Detrick, they have all the nasty viruses there. They also published an article about 5 years after my discovery, also showing that these mushrooms are highly potent in their antiviral activity. So it's good because other virologists had proved something that I had discovered earlier. The take-home message here for all of you, please consider potentizing your immune system using polypore mushroom mycelial extracts. No matter where you can get it from, if it's certified organic and truly you know the chain of custody, this is one of the best things to be able to provide an armamentarium of defenses against these pathogenic viruses that can affect you and your family. We don't know the mode of action in particular, but we know it upregulates the immune system. So it could be an entourage effect of these multiple compounds within the mycelium being expressed in these extracellular constituents, and that little bead droplets that you saw in the mycelium, those are where these potent compounds are coming from. So in the course of the research in virology, I was astonished to see this, was that oyster mushrooms are a source of shikimic acid. Now, shikimic acid is produced by the star anise plant. It's one that has the highest productions of any plant in the world. The shikimic acid is a precursor for Tamiflu. And many of you may remember about 10 years ago, Tamiflu became scarce when there was a bird flu epidemic that was on the horizon. And so all these people bought up Tamiflu, you couldn't buy it. Well, Tamiflu comes from star anise. It's only harvested twice per year around Afghanistan. So that supply chain is very challenged. But it was discovered recently that oyster mushroom mycelium, upon exposure to blue light, produces shikimic acid 24/7. So this may speak to why these mushrooms have these profound antiviral effects, is that they are exposed to light, and the mycelium that upregulates the production of these precursor compounds that then can lead to antiviral activity. We don't really know the targets against these other viruses that I've mentioned, but Tamiflu comes from shikimic acid. Shikimic acid now can come from oyster mushrooms all day long, an exposure of blue light. We don't have to have a weak supply chain coming from Afghanistan of the star anise plant that only matures once or twice per year. So a little bit of science here for you folks, but I encourage you to go to this website that I've constructed. It's unbranded. It's just for scientists and physicians. Please write it down or take a photograph if you wish. Called mushroomreferences.com. It's hundreds of pages long. I'm a victim of Google Scholar alerts. I read so many of these every week, and then I get the best ones, and then I upload these and the abstracts with jump points to the journals in case they're behind paywalls. But it's a really good summary that physicians and researchers are using, because there's so much of a chaos of misinformation that's out there. There's a propaganda machine that's in high gear right now, trying to dissuade people from finding out this information that I think all of you should benefit from. So check out mushroomreferences.com. So I want to show you how there's a strange crossover from my work with the biodefense program and the Bioshield program for discovering antiviral activities to being able to help the bees. The bees are in enormous decline right now. This study that came out 2 years ago, 75% decline over 27 years in a protected area of flying insects. Those of you who are a little older may have seen in the United States in particular, you have bug splatter on your windshields. We literally had to pull off the highway to clean our windshields because there's so many bugs that were splattered on it. Now you can drive for dozens of miles and rarely get a bug on your windshield. The decline in flying insects is enormous. This speaks to the loss of biodiversity and the unraveling of our ecosystem. A very strange series of events. You have the background now, my work for the Bioshield program and antiviruses and upregulation of the immune system and all this complexity. And I believe in the complexity of nature gives us our strength. But I want to show you several things that happened. And I was growing the garden giant mushroom back in 1984. There's my daughter Ladina that you'll meet here in a few minutes when she was very little, and my son. And there's a garden giant mushroom. It's up to 5 pounds per mushroom. I put this mushroom out in my garden with the wood chips, and I was growing it in the summertime. And the beds of wood chips are like 12-inch deep boards that go into the ground. And I come out in July, and I was surprised to see all these bees, and they're moving the wood chips aside and exposing the mycelium. And I looked really closely, and I could see the bees sipping on little droplets of the mycelium. I thought, wow, that's really interesting. I published this in Harrowsmith magazine. I put it in one of my books, Growing Gourmet and Medicinal Mushrooms, in 1994, and thereupon I more or less forgot about it. But I stated that in my books, well, maybe the bees are attracted to the sugars that are being excreted by the mycelium, these sweet polysaccharides. Well, the loss of bees is on the near event horizon, one of the greatest catastrophes that we face, threatening our worldwide food biosecurity. 35% of our food is dependent upon it, indirectly up to 70%. Bees are the proverbial canary in the coal mine. But what's happened with honeybees, which produce enormous amounts of honey, and big colonies, the majority of pollination benefits that people receive are from wild bees, from, for instance, like bumblebees. But because of a global spread of viruses, there's your typical bumblebee. And look at that poor bumblebee on the right that has the deformed wings. That's from a virus called the deformed wing virus. A bee can pollinate 1,000 flowers per day. Every almond you eat was visited by a bee. Honeybees used to fly for 9 days, now they're flying for 4. So their pollination services have gone from 9,000 flowers to 4,000 flowers. So when you see bees on a flower with honeybees, that's the last days of their lives. The problem is these viruses that honeybees have vectored to flowers, they leave viral particles on the flowers that wild bees then subsequently visit. And so all bees in the world now have these viruses. The viruses came originally out of Asia. Over the past 80 years, they've been transmitted now primarily by the varroa mite. The varroa mites are so large, it's like having a pancake on your back, you can't dislodge. They are constantly injecting a slew of these viruses. They get into the brood. The newly hatched bees are called nurse bees. They take care of the soon to hatch bees, but the colony is stressed because of lack of pollen. And so the nurse bees abandon the brood and they fly off to get pollen, and then varroa mites have free reign to inject more viruses. So these viruses are spread all over the world. I've talked to several beekeepers in the past 2 to 3 weeks who have lost 90% of their beehives. Think of that. Think if you're a cattle farmer and you lost 90% of your herd, or a sheep farmer, or a chicken farmer. These are devastating losses. And so now there is a 100% honeybee colonies in the world are infected. There's a global, worldwide pandemic. In the United States, this is from last year, the hotspot, Oklahoma, almost 84% loss of beehives, 70% in Nebraska, Nevada, 65%, Maryland, around 74%. But in talking to these bee researchers and bee scientists, these are reports from a nonprofit group called Be Informed, and in combination with the USDA. In fact, all of the beekeepers are underreporting because they're ashamed. They don't want to tell other people that they failed as a beekeeper. They want to tell other people they're great as beekeepers and their honey is wonderful. Behind the scenes, they're underreporting. It is far worse than people have heard. And now it's emanating throughout the ecosystem. So the loss of pollination services are stressing these farms. There's 1.2 million beehives right now in the California almond orchards, spread from all over the United States. It's a perfect storm because they're in close proximity, 1 to 2 beehives per acre. They exchange these viruses and then they're dispersed to the oranges in Florida, to other crops, apples and cherries. So we are a victim of the industrialization of the European honeybee. So these losses are not only staggering, but they threaten not only food worldwide biosecurity, but they threaten us as our lifestyles. Food will become more expensive. More people will be in poverty. When you have more poverty, you have less healthy conditions, you have more disease. It can make people really upset that they are impoverished and other people are not. So it stratifies society and creates a larger chasm between the haves and the have-nots. So this is truly an all hands on deck. So knowing this, I've had a series of experiences, and I was fascinated by how bears, when they scratch trees, resin will come out of the scratches, and bees will be attracted to get resin to make propolis, which is basically wax that's being packed into the cavities and cracks, because bees only have one entrance. So they're in a hollow log, for instance, they patch up all the cracks so they can guard the entrance, they control the exit and entry. And so when bears would scratch trees, these bees would come in, and then I was in the Olympics. I was deep in the South Fork of the Olympics. I came around the trail with my friends, and we all those bear scratches. This is the best bear scratch I've ever seen. So I told my friends, well, that's interesting because this scratch, should grow polypore mushrooms. My neighbor killed 400 bears. And he was bragging to me. I go, what do you do? And I said, I'm a bear hunter. I've killed 400 bears. I go, why are you killing so many bears? He says, well, we're killing bears because in Washington State, bears scratch trees, polypore mushrooms grow, and the trees die, and the schools are funded by the timber harvest on state lands licensed to the logging companies. So the schools in Washington State were funded by trees. The more loss of trees from bears threatened the educational funding. So the great wisdom of these state officials, they decided to kill the bears. So he killed hundreds of bears. And when I live on Skookum Inlet, several salmon runs a year, not a bear to be seen. So, horrible story. So we came back, and there's that same tree, 2 years later, and sure enough, a polypore mushroom called the red polypore mushroom is growing out of it. So the summary of this research came about because I had published this information, and then a friend of mine, Louis Schwartzberg, who's a filmmaker, we did a Walt Disney film on pollination, said, Paul, the bees are really in trouble. I said, no, I heard about that. He said, can't you do something to help the bees? And I had a waking dream. And this dream came to me, and I had this epiphany, and I got real excited. I said, I think I'd be able to use these extracts in the Bioshield program to reduce the viruses in bees. These mushrooms grow on wood. They're polypores. We all grew up with Winnie the Pooh. Bears scratch trees, mushrooms rot the wood, they create cavities, bees go into the cavities to set up homes. Maybe the bees are getting an immune benefit from following the path of mycelium in rotted wood. That was my epiphany. So I called up the University of California at Davis, and I quickly learned a lesson. Never call up another scientist with the opening words that I had a dream. The guy said, I don't have time for you, thank you very much, click. So, okay, I'll try a different track. So I called up Washington State University, and I pulled out all the attributes I could. I'm a TED speaker, I work on the Bioshield program, I publish on this. You know, and the guy, and he said, after 15 minutes, he goes, go nowhere else. We want to work with you. We'll give you the full efforts of our research department at Washington State University. And so the summary of this research is a red-belted polypore, the one that the bears introduced, that they killed the bears for. Amadou, Fomes fomentarius, which some of you see my famous hat is made from that. The red reishi, and chaga. These are the 4 species that show the best evidence of helping the bees. We did the largest clinical study in the history of bees, 2017, 532 beehives with mycelial extracts, cooperation with the USDA, Washington State University, and our team. The summary of this research showed that the antiviral effects of feeding Amadou and reishi mycelium decreased the deformed wing virus 879 to 1 and 80 to 1. This is 1 drop of the extract into 100 drops of water. So 10 mils per liter, or 1 mil to 100 mils. So a very small amount of this extract is put into the sugar water that beekeepers commonly feed bees. And so Dr. Jay Evans, who's a USDA virologist specializing in bee viruses, said, I've never seen anything that has reduced viruses more so than in Stamets' extract. The other virus is the black queen cell virus. All queens now are infected. And so the black queen cell virus is threatening the queen stocks, and they're being transmitted and passed down. We found that chaga reduced the black queen cell virus 500 to 1. Reishi reduced it 500 to 1. We found that reishi reduced the Lake Sinai virus 45,000 to 1 with 1 treatment, 12 days after treatment. We found a consortium of these polypore mushrooms reduce these viruses thousands of times, hundreds or thousands of times, with significant confidence that the data is valid. So again, when you have p-values that have 2 or 3 zeros in front of them, that means it is unambiguously clear that the results are valid. A p-value of 0.05 means you have about 95% confidence, 0.01, 99% confidence. So these are extraordinarily active. So a summary of this research shows that Amadou, reishi, and chaga reduce different viruses extraordinarily. And then when we did the longevity tests, we found that a red-belted polypore and Amadou, in hand, the bees live about 30 days. These are cage experiments. So basically, we functionally doubled the lifespan of bees. So ostensibly, this would mean they wouldn't fly for 4 days anymore. They'd be back up to 8 or 9 days and return their pollination benefits to the ecosystem. So Dr. Steve Shepard says after 40 years of experiments studying bees, there were any materials that extends the longevity of bees more than this. So I went ahead, I did apply for patents. I have been issued patents now in 40 countries: United States, Canada, Europe, Eurasia, Australia, and New Zealand. I've open sourced it for the majority of the world. Costa Rica, India, South America, Mexico, Japan, China. I was about to open source this, and I was contacted by a well-known pesticide company who was really excited because they heard I was going to open source this and they wanted to use it. And these are the people that are promoting and selling glyphosates and insecticides. And it was a clear example to me of greenwashing. If I did not patent these and I open sourced them, then it'd be like BP. In the United States, BP, all the commercials are beyond petroleum. Are you kidding me? 99% of their money is in petroleum, and 99% of their advertisements is said they're going to go beyond petroleum. This greenwashing. So I realized when I had these phone calls with these individuals, they were so excited about using my technology, they wanted to use it for advertising.
I said, I'm not going to let people walk on my invention and exploit the people by spreading a lie that they're involved in something they're not involved in. Now, when I first got the first patent, I like to say the first 5 seconds, sure, my ego swelled. But then I thought, wait a second. And the only reason why you get a patent is that there's no prior art. No one's ever mentioned that bees will benefit from rotting wood with mycelium immunologically. Anyone mentioned that, the patent would not be there. It's called prior art. Any language. It is search engines in Chinese, Japanese, German, Italian, etc. Massive search engines. No one had ever made this connection. And it's against conventional wisdom, which is great, but I have critics out there that say, and have said, Paul Stamets is full of bullshit. He doesn't know what he's talking about. So my message back to them, if you ever hear anybody say this about me, tell Paul I have the message to you. Thank you. Because it's against conventional wisdom. You want experts to say, that's not going to work. You want people to criticize you, to say that you're full of shit. So that is against conventional wisdom. There's no prior art. Then usefulness. Well, obviously it's very useful. So this is our research team. And then we created a campaign. Some of you are aware of this. End caps in stores, all through the nutritional supplement industry, through Vitamin Shop, Whole Foods, Sprouts in the United States. They're big vendors of supplements. And we created a QR code to support research at Washington State University. I had no idea until they gave me the report. This is with your iPhone or Droid. You can go by and you can scan a QR code in about 10 seconds, double click, and through Apple Pay, contribute $50 to Washington State University. You can do this on the fly in about 20 seconds. Well, they gave me this report. We have raised over $6 million for Washington State University. So we submitted our article for publication. And those of you who are, how many people here know about Nature? It's the most prestigious scientific publication company in the world. And we published in Scientific Reports, which is a Nature publication. And I checked the other day, and we are in the top 1% of all articles ever published in the Nature publication ecosystem. The top 1%. The reason why I think this is true and is important is we've been able to demonstrate that a natural product based on the complexity of nature, the mycelium, and all its complexity, offers a broader bioshield of benefits than a pure pharmaceutical. We're the first evidence that I know of that. A natural product can give you more protection against pathogens than a pure pharmaceutical because of the complexity of the compounds that are resident within the mycelium that is evolved within the complex biosphere of nature. So this, I think, is an opening door for a potential huge amount of discoveries. So you young scientists out there investing in these natural systems and understanding the synergy and the entourage effect of these compounds is really important. So what can we do? So I'm challenged by this. I want citizen scientists to come together. So I invented this little bee feeder where you can put the extracts into this. It's based on a maze. Bees will navigate through a maze better than wasps and yellow jackets. And I set this up with the extracts in my garden. First visitors were 2 bombus species, 2 bumblebees. This was fun. And so we created this bee mushroomed bee feeder. There's a little CGI here that we created. You can hang these in vertical gardens, in apartments. You can hang them outside your house. You can put them in the extracts. The bees come and they visit them. They sip on the extracts. And it lowers then the viral population within the ecosystem. Now we are putting cameras on it. We upload it into the cloud, into the data sets, and we plan to have millions and millions of these bee feeders spread across the planet to be able to collectively understand how the pollination services are being stressed, how they're being repaired. You can go to beemushroom.com, and I'm giving away 10,000 of these for free. 10,000 of these for citizen scientists for free. We have now coordinated with a very large computer company. All of you know it. You'll be hearing a lot more about it. We have now 400 acres of canola. We're putting 1 per acre. The idea with the cameras and then being able to upload it into the cloud, all these bee feeders become a new Wi-Fi source of a distributed network, so they got excited about that. I want to have facial recognition of bees. When I told them, they go, "Ooh, that's challenging." But the idea is to be able to count the bees, the facial recognition, be able to species identification, and we can collectively have this wherever. We'll open source this for 3D printers, so anybody who has 3D printers will open source it for schools. So I'm dedicated to giving away, 10,000 of these bee mushroom bee feeders. You go to that site and you sign up for it, and if you got skill sets, that can help us, that we want to spread this all across the world. So, in closing, what can we do? Well, one of the most important things you can do is leave wood on the ground. Let wood rot. When you have a storm and you're encouraged to pick up the wood and move it, keep it in there on your property. Don't take it away. When you do that, you're taking away carbon from the carbon bank. And so, storms subsidize the debris fields that help the fungi grow, that can help the bees and other members in the ecological community. Give up the concept of the Elizabethan yard. If you're in the United States and, these neighborhoods, you got a neighbor with a really disheveled yard, well, there's a lot of fractal faces for biodiversity. It's that neighbor who has got the unkempt yard that looks crazily full of debris fields. Those are people that are protecting the biodiversity, not the people that are mowing their yard every day, spreading chemicals to make it look like a golf course. So it's really important that we let wood rot. So the mycelium is the immunological network of nature, the foundation of the food web, influencing the health of animals and plants and species resident within. Citizen scientists, I'm hoping we can all unite as a community. And I have created a new cryptocurrency that's in the making called the fungo. Like the euro, right? It's the fungo, right? So we minted 1,000 of these coins. We're minting another 1,000 of them, the one on the right with the famous bee man on it. We'll tie it to cryptocurrency. The idea is the first cryptocurrency that I know of that is tied to an ecological metric. A cryptocurrency that will be able to fund the research for us to give away these bee feeders, to be able to add the technology to them, to be able to spread the extracts far and wide. Because we are on this Earthship together. We hold each other's health in common to our own health. The idea that we are separate from nature, we're not a part from nature, we are a part of nature. So it's critically important that we gather our skill sets together. The idea of the cryptocurrency, for those who want to know how it's being monetized, if you have a canola field, you have the bee mushroom bee feeders out, you notice that baseline, you're getting several hundred bees per day. And then you see the next year, you're only getting a dozen per day. Pollination services are going to go down. The canola crop is going to fail. Canola prices are going to go up because of scarcity of yield. And then you can be able to monetize this by protecting the prices of the commodities. So the idea is then to give 10%, hopefully, of all the proceeds coming from the cryptocurrency to fund nonprofits, to social networks, to people who are socially responsible, and to be able to help the commons for those people who can't afford to put these technologies in place. So I want to show this short little clip from Fantastic Fungi. It's only 2 minutes long, but it has a good message. So, whoops. I guess it's not coming. Oh my, I have little problems. We'll try it again. There it goes. We have the volume up, please.
The mushroom mycelium represents rebirth, rejuvenation, regeneration. Fungi generate soil, that gives life. The task that we face today is to understand the language of nature. My mission is to discover the language of nature of the fungal networks that communicate with the ecosystem. And I believe nature is intelligent. The fact that we lack the language skills to communicate with nature does not impugn the concept that nature is intelligent. It speaks to our inadequacy for communication. If we don't get our act together and come in commonality and understanding of the organisms that sustain us today, not only will we destroy those organisms, but we will destroy ourselves. We need to have a paradigm shift in our consciousness. What will it take to achieve that? If I die trying, but I'm inadequate to the task to make a course change in the evolution of life on the planet, okay, I tried. The fact is, I tried. How many people are not trying? If you knew that every breath you took could save hundreds of lives into the future, had you walked down this path of knowledge, wouldn't you run down that path of knowledge as fast as you could? I believe nature is a force of good. Good is not only a concept, it is a spirit. And so hopefully the spirit of goodness will survive.
Biodiversity is biosecurity. Humans, trees, bears, mushrooms, the birds and the bees, we're all interconnected within mycelial internet. And I want to bring to your attention as a call to action, on March 26th, more than 500 theaters worldwide are all coming together to show fantastic fungi. So if you have not seen the movie, please go see it. If you want to sponsor a theater, go to fantasticfungi.com. This is truly a grassroots movement. We're all in this together, but there's an upswelling. Something felt like I've been a lone ranger for so long. And now to see all these young people engaging mycelium, teaching workshops, teaching people how to grow mushrooms, and spreading this mushroom knowledge gives me great hope for the future. Because I think we can invent our way out of 6X. But it's going to take all of you to step up to the plate to do something about it. And so let's not get depressed and distressed. We can be optimistic about what we can do. Because we're smart enough as long as we respect and invest in the intelligence of nature. So we will always, forever exist within the molecular matrix. Let's take off together. Thank you very much, folks. Thank you, Envision. Thank you, Stephen, Brooke. Thank you so much. Jay and everybody else, and Sarah, everybody else has participated. And I would like to bring up some of the organizers and my daughter, Ladina. So she's bigger now. She's part of the tribe. Stephen is probably out partying. Well, you'll have to accept them for